All right, we're back. We're on page 7 of notes 1 of Calc D, multivariable stuff, talking about three-dimensional vectors now. We just defined the cross product. So u cross v, it's a vector that's orthogonal to the two vectors u and v, which means it's at right angles to both of them. That means the dot product of u with u cross v will be 0, and the dot product of v with u cross v will be 0. And the easiest way to remember it is by using a 3x3 determinant. So let's do that and see if we can find it. So we have to find v cross w and w cross v. So v crossed with w is, okay, so you fill in I, j, k. You get to the point in life where you can do these, it's always helpful to write it down, but like after you write it down, eventually you'll probably be able to do it in your head. So it's gonna be I. Okay, now you cross out the row and the column. Row, column. So it's 2, 1, 1, 1. So 2, 1, 1, 1 is what we're like worried about. And now from there, we're going to do diagonals. 2 times 1 minus 1 times 1. I'll write it 2, 1 minus 1, 1. Now this minus sign here is the thing you're going to get wrong. So it's minus j. And then we cross out the row and the column. We're left with 1, 1, 3, 1. But we do diagonals. So it's 1 times 1 minus 3 times 1. 1 times 1 minus 3 times 1 plus k. Okay, row and column, gone. So it's 1 times 1 minus 2 times 3. 1 times 1 minus 2 times 3. And then we simplify this. So we get I, and then plus 2j. And then minus 5k. Okay, so that's what we got there. Now, if we were to do, which I guess we're going to, if we do v, I gotta make this smaller or something because I took up like a lot of my space. How much smaller can I make this? Sometimes it kind of lets me shrink things, and then other times it's like, no, you can't do that. All right, not bad. I mean, it was bigger. You know, it's bigger here. So if you need to see it, screenshot that or whatever. Now, if I do w cross v, let's see what happens. I already know what's going to happen, and so do you if you think it through, right? We're swapping 2 rows in a determinant. 3, 1, 1, 1, 2, 1. If you swap 2 rows in a determinant, what happens? So we get 1 times 1 minus 2 times 1 minus j. 3 times 1 minus 1 times 1 plus k. So I hope that you've done determinants before. And if you haven't, I mean, it's not the end of the world. You might have a little reviewing to do. Well, not reviewing, I guess a little learning. So this is going to give me negative I, and then minus 2j, and then plus 5k. And if we look, this and this are just opposites, which confirms what we thought. We thought that v cross w would be the negative of w cross v, because when you swap 2 rows of a determinant, you change the sign. So it makes sense that that happened. Let's try the next one. So this, I don't know if I was trying to make a point here. It seems like it'd be really nice to multiply this by 6, get the cross product, and then divide by 6. And do we think that'll work? I mean, I think that will work because we're introducing a factor of 6 everywhere. So we can multiply by 6 and then get our answer and divide by 6. It looks like the numbers may have been designed to work out though. So let's see. If I know me, they were not, but who knows? All right, v cross w, it's going to be I, j, k. So 2/3, 1, 1/2, 4, negative 6, 3. All right, so it's going to be I, and then you cross out the row and the column, and you do diagonal. So it's 3 minus negative 3 minus j. So if you have to rewind, like pause, rewind, look at it again, like do it. There's nothing wrong with that. The minus in front of j is the thing you're going to ultimately get wrong accidentally when you're like under pressure. we cross out the row and the column. So it's 2 times, so 2/3 times 3 is 2, and then minus 2. So 0, that's interesting. Plus k, row and column, row gone, column gone. 2/3 of -6 is -4, and then minus 4. So -4 minus 4, which I guess is -8. Well, I mean, I know that's -8, but so I get 6i minus 8k. All right, if I did that right, I kind of think it's right, but like, who knows? So it's 3 minus -3, it's 2 minus 2, and then it's -4 minus 4. Yeah, I think that's right. So that means that W crossed with V should be the negative of V crossed with W. So if I got it wrong, I'm doubling down, and I'm going to get -6i plus 8k. There's no j term there. All right, I'm going to switch over to the calculator and just confirm these or refute them. And then I will probably wrap up this and come back in the next video and do a little bit more. So let's see. I'm going to insert a new problem. So doc for problem, calculator page. Let's define them. V is going to be 1, 2, 1. W, I store more vectors, I think, than definitely on the handheld. It's more annoying to store vectors. So like you may store less frequently than I do. All right, menu 7, option C, and then option 2 is cross product. So V comma W. 1 to -5. Got it. Let's try W crossed with V. -1, -2, +5. Makes sense. What if we cross a vector with itself? Well, if 2 rows of a determinant are equal, the value of the determinant will be 0. So V comma V should give me zeros. And then W comma W will do the same. So these are, you've got to like confirm these things for yourself, you know, just like see what's happening. Let's redefine our vectors and do the second problem. So for the second problem, I talked about how I thought it might be easier to scale up V by a factor of 6 to clear out the denominators. Because like sometimes things are just easier when there are no fractions involved. First, let's see. So that's menu 7C2 is cross product. Menu 7C2 cross product. V and W. 6, 0, -8. So then if I do W cross with V, I should get the opposite of that, which I do. Now let's try this. So I want to do the cross product of, I want to multiply V times 6 just to clear out the denominator. And then I'll cross that with W. What I think is going to happen is I'm going to get 6 times the cross product of V and W because I'm crossing 6V with W. So if you look at it, compare it, let me get this out of the way. You actually do get 6. So I could have scaled it up by 6, gotten my cross product, divided by 6. That would have been totally effective, might have made everything easier. I mean, these are you play around with this. And when you play around, that's how you like really learn what's happening. The other thing we want to like just see is, you know, the dot product of this cross product with V should give me 0, right? Because the cross product is orthogonal to both vectors involved, and it does. If I cross it with this, I should get 0 because the cross product is orthogonal. It's at right angles to both vectors that you're crossing. And we do. That's like the geometric thing of a cross product. So this all makes a lot of sense. So that's kind of a lot of stuff, especially if you're not super familiar with the determinants, the whatever, 3x3 determinants. This could be a lot for you potentially. So I'm going to go back to the notes and then I will just show you what we wrote and wrap it up. So that's calculator stuff. All right, next video, we're doing another one. We're going to really kind of talk about those and then we'll end up moving on. So cross products, big deal. You got to understand them. So make sure you do some practice. I'll see you in the next video.